Hi you guys, this is Miss Clay Logan. I want to remind you guys to go ahead and get out any a writing utensil and notebook paper so you can take notes along with us. We will pause throughout for you guys to copy stuff. So you want to write all these problems down and label the sections with what the section of the slide says. So today we're talking about inverse functions. You guys probably think of inverse as like opposites. And that is a lot of what inverse is, but opposites in math refer to the inputs and the outputs. So when we find the inverse, we're referring to switching the input and the output of a function. In other words, the x and the y. So if here's my xy, xy, xy. If I were to switch that, instead of 3, 2, I'd have 2, 3. Instead of 2, 4, I'd have 4, 2. Instead of 6, 7, I'd have 7, 6. So that would be like how we would switch like coordinate points. Instead of writing the f of x, in order to say that it's the inverse, I put a little -1 sign. Because if I did not put that -1, we wouldn't know if it was the original or the inverse. So this is the original, and this is the inverse. Okay, so we're going to think of f of x equals 2x minus 4. The first thing we're going to do is this is the same as y equals 2x minus 4. I'm going to take it out of that notation. And then I'm going to switch my x and my y's because I'm switching my input and my output. However, we are not used to seeing things with x by itself and x isolated, so now I'm going to try to get y by itself. To do that, I'm going to add 4 to both sides. I almost have my y by itself, so I'm going to divide everything by 2. I end up with x plus 4 divided by 2. And now I need to say what that's equal to. So that's the f function, but it's the inverse. So I found the inverse of the f function. That's what the f of -1 says. I want you guys to pause this and try this one on your own. I will show the answer here in a second, but you're going to pause it and try g by yourself. Okay, so we should have gotten x minus 4 divided by 3 is the inverse of g. So this little -1 there is what tells us what the inverse is. Okay, so this asks us, this tells us one-to-one functions, g and h are defined, and then it asks us to do some operations with that. So we're going to take a second to define what one-to-one function is. I want you to write down this definition. A one-to-one is only one input to each output and only one output to each input. So that means that no x's repeat and no y's repeat. So it gives us these two, g and h. Let's start with the inverse of h of 4. So when I input 4 into the inverse of h, so first let's find the inverse of h. I want you guys to try to do this on your own because I just did this on the last page. So pause your screen and I want you to switch all of these points. Go ahead and switch all of these points, find the inverse. So I switched all of my inputs and my outputs. So my x's became y's and my y's became x. This one's known my input is 4. So I'm going to go to my h -1 or my inverse of h. When my input is 4, I got out a 1. This is asking us to find the inverse of g. So this is like what we're doing on the first page. If you feel like you can do this on your own, I encourage you to pause and do this on your own. So we're going to start with the g function. We're going to switch our x and our y. Or we're going to write it without, sorry, first step is writing it without the x, the g of x, we're going to write it as a y. Step 2 is switching my x and y. Step 3 is getting y by itself. So I'm going to multiply both sides by 11. I almost have my y by itself. However, I'm not done because I started with a g of x, so I need to write that this is the inverse of g. Sorry, I forgot the x there. It's 11x minus 8. So my inverse of g is 11x minus 8. So my inverse of g is 11x minus 8. What the second part is asking for is it's asking us to take our inverse function and inside of that put the g of 3. So this is really similar to what we did last lesson with function composition. So I'm going to find out what g of 3 is first. So everywhere I see an x in the g function, I'm going to put in a 3. So that gets me 11 divided by 11. Or just 1. So now I know this is really asking for the inverse of 1. So I'm going to take the inverse function, and wherever I see an x, I'm going to put a 1. And that gets me 19. So you guys are going to want to copy this slide. Okay, the next topic we're doing is cubic root inverse functions. So you guys are going to write this title at the top of your notes and start taking these along with me. On the last slide, we talked about what one-to-one function is. Means each input has one output and each output has one input. So it's asking us to find the inverse of f. So I'm going to start with my original f function, the cube root, and I'm going to replace, when I see the f of x, I'm going to put a y. And now I'm going to switch my input and my output. So where I had an x, I put a y. Where I had a y, I put an x. I'm now going to try to isolate my y. And this is where it becomes a little different than what we've done. So we have to think of what is the inverse operation of something cubed. It'd be taking the cube root and the cube are inverse operations. If I had a square root, the opposite of square rooting something is cubing something or squaring something. So here I want to get rid of that cube root, so I'm going to cube both sides. So I'll get x minus 7 cubed equals 1 minus y, because the cube and the cube root undo each other. I'm going to subtract 1. I'm going to start writing this over here. So I end up with x minus 7 equals negative y. What I don't like about this is the negative sign there. So I'm going to divide everything by a negative 1. I get negative x minus 7 cubed plus 1 equals my inverse of x, or my inverse of f. Okay, so now the next section, I want you to write this down. The inverse function of cubic, or quadratic and square root. So it's the same idea of what we had last slide, where my cube root and cubic are inverses, and my square root and x squared or quadratic are inverses. So it's asking me to, given this f of x, find the inverse and state the domain. So I'm going to start with my f of x function. Then I'm going to replace my f of x with a y. Then I can switch my input and my output. This comes back to the idea that we have up here. I want to get rid of this x squared. So the inverse operation of that is squaring both sides. So I'm going to square both sides. Squaring both sides will get rid of, or square root both sides. I square rooted both sides. Square rooting both sides will get rid of that squared. Subtract 4 from both sides. I cannot leave this as a y. I need to write this f negative 1, or the inverse of f. And this minus 4 is outside of the square root. It is not underneath the square root. And then it also asks for the domain. So we need to remember the square root function. If you remember what it looks something like this. We cannot put a negative number into the square root. So my domain would be, but we can put a 0. Anything above 0, we can input into this function. Oh, I didn't mean to erase that. Okay, so this next one is asking us to figure out how to graph. So when we graph, we still use this idea that we have 3 points. We are going to make, we have points, and we can switch the x and the y value. So for the original function that we have, I want you guys to write the coordinates for those 3 points, and then I want you to switch them to find the inverse. So go ahead and pause and do that on your own. Okay, so we took these 3 points. Sorry, I made a mistake. This should be -3, +3. Now I can plot those 3 points to get my inverse function. So I have 6, 4, -3, +3, -5, -3. Then I connect those. Oh, sorry, my 6, 4, my -5, -3. I do not know why it keeps taking away that dot. So this one would be my inverse function. This one would be my original function. And that is how we can do it if we're ever given a graph, and we wouldn't have that little line there. So there's going to be a part 2 to this video. So we just did the first part of inverse functions.